Greetings! Have you ever wished you could use an Icom remote automatic antenna tuner, those we install up on a tower outdoors, such as a model AH4 without an Icom transceiver available? Well, this project is a standalone Icom antenna tuner controller box which allows to use any brand of radio with these remote antenna tuners. The Icom tuners are great machines, no doubt about it, but because of the uniqueness of their control interface, normally the only way to operate these antenna tuners is to connect them up to an Icom HF radio transceiver using their 4-pin Molex connector. Well, one day I decided to browse around and see if I could do anything about it, because I wanted to use my half-sloper antenna, which is connected up to my Icom antenna tuner, and I just couldn't, because first of all, if you turn off your transceiver, the antenna tuner up on my tower is not pass-through. It's offline. The antenna is not connected to the coax. So the first thing is you need to power up the antenna tuner. The second thing is, in order to operate the antenna tuner, you need the Icom transceiver. So if you want to use an external transceiver, whether it's a QRP transceiver of any other brand or a bigger HF radio, well, you first have to tune up the antenna using the Icom radio, if you have one, of course. And then once it's tuned up, you leave the Icom HF radio on, you just disconnect the coax and swing it over to your other radio, and then it's going to be working. But as soon as you want to change bands, you need to disconnect the coax from the non-Icom radio, reconnect it up to the Icom transceiver, tune up on the other band, disconnect the coax, swing it over to the non-Icom. You see the kind of operation that's just really bad. And if you happen to have an Icom tuner but you don't own an Icom transceiver, what do? Well, this box will do it. And it will also support an Icom radio. So quickly, here are the features. If you're down to radio, the antenna tuner is bypassed from this controller. It's just connected up to your Icom radio, normal way of operation. If you want to control your antenna tuner from this box, you flip it over to controller, and then the box will turn on, and you'll be able to tune by pressing here, or take it offline, so in pass-through, untuned, by pressing here again. And we have status LEDs that will tell us if the tuning was successful. There's a PTT line, because yes, this box will put the non-Icom radio in transmit if you wire it up properly from this box to the other transceiver. So this is the front, and then the rear, it's a Phoenix. You can remove this block. It's a Phoenix 10-pin connector block, and you hook up your tuner, the antenna tuner itself. It's a 4-wire interface, and the radio, 4-wire interface, right? And then you have a PTT, and you do supply 12-13 volts here in order for the antenna tuner to operate when you're not using the radio. So the Icom radio is optional, but of course if you want to quickly switch between Icom radio operation of the tuner or this box for non-Icom radios, the switch here allows you to do so. I did not have to study how the AH4 or other Icom antenna tuners work. Chris, K9EQ, did a wonderful job of analyzing and describing the inner guts and the operation of that antenna tuner. And this document that I found on the web tells us exactly what we should be doing with the 2 signals that control the antenna tuner, which are start, this one we send, and key, this one we monitor. So 2 wires other than, of course, 13.6 volts and ground. By looking at these timing diagrams with, of course, when to send RF, we can easily find out whether tuning was successful, depending on the key signal sent back from the tuner. And we know what signal to send on the start line to tell the tuner to go offline, or if you want, pass-through instead. Thanks, Chris, for putting everything in writing. So the schematic is relatively simple, it fits on a single page. I use the RP2040 Zero microcontroller, which is a mini Raspberry Pi Pico. So same processor, fewer pins to make it much smaller, actually about 40% of the surface of a Raspberry Pi Pico. And it has an RGB LED built in, like on board, which we don't use here. But otherwise, the code is compatible once we reassign the pins, of course, compatible with the Raspberry Pi Pico. So very easy to use. All the libraries created for the RPi Pico can be used on the RP2040 Zero. So 5 volts is provided to that microcontroller board, and there's an onboard 3.3 volt regulator that feeds 3.3 to our INE 226 board, which I'll come back to in a minute. So we take 13 volts from external, not Icom radio, to be sent to the whole circuit. There's a 5 volt regulator that supplies the microcontroller. On the indication side, I use a dual LED, dual meaning red and green, integrated into the same lens, and they're connected back to back, which means depending which pin you put high or low, you get green or red. There's also the PTT LED, which is wired up to the output PTT line directly. So for sending a start signal to the tuner, or receiving the key signal from the tuner, or even for sending a PTT to the non-Icom radio, I use AQV212 solid-state relays. There are other AQV versions available, but I've selected AQV212, which can switch 550 milliamps and up to 60 volts. So it's a pretty versatile chip. It is polarity agnostic because it's a back-to-back MOSFET configuration, and it can provide galvanic isolation, though here the ground is common, so we don't really use the galvanic isolation. These nice beasts sell for about $1 each if you buy a lot on AliExpress. I like them a lot because they replace a transistor and accompanying resistors for biasing and pull-up and so on, and they're quite reliable. They're DIP 6 package, so they're not too large, and I put them on sockets. Now, one of the features I've added is the ability to detect whether the tuner is present or not. So the controller knows whether the tuner is present and powered up by measuring the current drawn by the tuner. So I have this current monitor. It's actually current and voltage monitor, but I don't really measure the voltage. I measure the current, and if it's more than 200 milliamps, I know that the tuner is there and the controller can proceed normally. If there's no current detected, it means that there's a miswiring or something's happening with the tuner, and a red LED will blink on the box telling the user that the tuner is not available. And this board is I2C read and written to. Okay, how do I toggle between Icom radio control of the tuner or this controller controlling the tuner? Is by using a 4-pole toggle switch. 4-pole double throw, meaning 4 sets of contacts. So if we exclude the ground, all 3 other signals of the Icom interface are switched between the Icom transceiver or this box. And in addition, I switch the power to this box. So if we flip into Icom mode, Icom transceiver mode, so basically bypassing this controller, it turns off the controller. So that's it for the schematic. So I took the top cover off and we can see the inside of the project. This is prototype version 1, but everything that's on my website has version 2, which is an upgraded version of what you see here. Essentially, instead of having 9 wires here going to the switch, there are 12, and I made small location adjustments as well on the board. So what do we have? We have this RP2040 Zero. This is the microcontroller, and it controls everything inside. We have under here the INE 226, this little daughter board that you can buy from AliExpress for less than $1 actually. And this measures current and voltage of our antenna tuner. This is how we detect, like I mentioned, if the antenna tuner is present. These are the AQV212. These are the solid state relays. I used 3 of them, and I mounted them on sockets, IC sockets, in case, unlikely event that I would blow up one of them, I can replace them easily. Push button on the front, 2 LEDs, one is bicolor, and the other one I use bicolor, but it's only wired up for red. Okay, so that the 2 colors are identical. You could actually make it green if you wanted to, but I think PTT should be red. And then the rear part, that's the Phoenix connector block, which you can extract by pulling a bit hard. I'll use my 2 hands. And you just pull the block and it disconnects from the rest, and then you can wire it up to your cabling. And once you're done, you put it back on, it snaps in. I haven't fastened the board yet to the enclosure. The enclosure is holding the PCB. There are 2 slide rails, one on each side, and the PCB is designed so that it slides into this enclosure, which is also available on AliExpress for less than $10. And yeah, the PCB, I haven't attached it yet. It's still in the slides. What I suggest is you put a little bit of glue along the rail, maybe, that will hold the PCB in place, because it does indeed require some force to insert and extract this block if you ever want to. It's fused like you saw on the schematic. The 1 amp pico fuse is right here. All the intelligence, of course, is inside the RP2040-0, a subset of a Raspberry Pi Pico, more or less, but smaller. That microcontroller is also mounted on SIP, single line pins, so I can remove the microcontroller if I wish to, just by pulling up, if I ever need to replace it. There's a USB connector on the microcontroller. The enclosure, which is a standard enclosure, its dimensions are 88 wide by 38 high by 100 millimeters long. So it's a standard enclosure, and you'll get that, like I said, for less than $10, about $8 US. Now, in addition to the project PCB, I also manufactured front and rear faceplates as PCB. These are cheap. They take much more time to design than they cost. They actually cost $4 a piece, for actually 5 of each. $4. That's the special deal that JLC PCB offers. So they're less than 100 millimeters wide, so they fit in that special deal. So I basically used black solder resist, white silkscreen, and I did design a copper shield here on the back to sort of limit EMI radiation. And everything is calculated so that this toggle switch, the push button, and some standard LED sockets fit in here. And on the back, of course, the signals are identified, and there's the big cutout for the connector here. I also provide these on my website, the Gerber files, if you want to order these. These are, like I said, custom designed for this enclosure. So you won't need the 2 faceplates that are provided by the enclosure manufacturer. So we've covered the hardware. Let's go see what the software looks like. The software, actually the firmware we should say, because it's a microcontroller, is written in MicroPython, which is a subset of the regular Python programming language we all know. But it's really, really close to Python. There's essentially no difference in all of this code here. There's nothing different from regular Python. So you're not lost if you do MicroPython instead. So the firmware uses one nice feature of the RP2040 microcontroller. It's double cores. It can run 2 processes, we say 2 threads at the same time. And I've split the threads. One thread does the main processing, main control of the antenna tuner. The other thread does LED management, LED flashing. So the cadence, the flashing cadence, is not disturbed by whatever's happening with the antenna tuner control. It's a nice to have feature to have 2 cores like this to be able to run some code. So I'm not going to go into details. I've put enough comment into the code other than high-level comments such as, I found an INA 226 library that I import into my code. It's by Christian Becker, so it saves time by not having to define all the commands, all the registers of the INA 226 chip, and a single one-liner command allows to verify whether the current is more than 200 milliamps. So decide whether to show a red flashing error or everything is good to go and we can process a tuning process in the code. So that's a very neat library, very simple to use. And what else can I say? Well, it's really processing the timing of the pulses, sending the proper start signal to the tuner, and then monitoring the key signal back from the tuner and manage the PTT line accordingly. And by analyzing the key signal coming back from the tuner, we know whether tuning was successful or not. And if it's successful, we show green on the status LED. If it was not, we show yellow. That's essentially how this thing works. The code, of course, is available on my website. Okay, so here's a quick demo. Antenna tuner is hooked up. Through SDX QRP transceiver hooked up as well, the PTT. So if I press a long press on the switch and I release, the transmitter will go and transmit. You'll see it will go PTT red here, and at the same time it will tell the tuner to tune, and then tuner will reply with a valid or invalid status when after it's done. So I let go. There we go. Green means tuning was successful. I can do it again, no problem. I'm on 3550 kilohertz on the 80 meter band. There we go. If I want to take the tuner out of the line, a quick press, and the tuner just responded by going into through mode, the pass through, and now it says yellow, meaning that the tuner is not engaged. The antenna is connected directly to the radio. Again, long press, tune successful. This is version 1, the prototype. If I flip the switch to radio, it will disconnect the power to the antenna tuner, and you will see what it does. Flashing red means that the antenna tuner is not seen. Its current is VCC current, it's 12 volt or 13 volt current, is not detected by the controller. If I re-engage, it will show yellow as the default status when you turn on the system. If for whatever reason it does not succeed in tuning up the antenna, I will disconnect the PTT here to show you. Now, when I ask the tuner to tune, since no RF will be sent because I disconnected the PTT, it will fail tuning. So I do it. There we go. Flashing yellow, then yellow. What it says is that it did not succeed in tuning up the antenna. Okay, so you saw it. I can do it again. There you go. Because no RF was sent because I disconnected the PTT. Now, we can always manually send RF and then call for a tune-up, like I do here. And it succeeded. So, wiring up the PTT is not mandatory. If you want to send RF to the tuner manually, that's fine. Send, call for a tune-up, and it will succeed. Maximum 10 watts of RF should be sent to the tuner. It's an Icom requirement. Do not send more than 10 watts because the relays will take a beating if the tuner tries to tune and there's too much RF. Okay, so make sure you reduce your power from your non-Icom radio. Normally on an Icom radio, the radio will automatically go lower in power when there's an antenna tuning request. There you go. If you wish to replicate this project, or if you're just curious and would like to read more about it, you can visit my website at ve2zaz.net, ve2zaz.net. You'll find the project in the menu here on the left, and everything you need to put together this project is detailed here, including the Gerber files to have the PCB manufactured, as well as the faceplate, their Gerber files. It's all available on the website. And I've also added a list of required components and some assembly and integration instructions. Everything is there. Go have a look. All for now.